Está con nosotros el doctor Claude Laporte. Voy a introducir al doctor Claude Laporte. El doctor Claude Laporte es profesor desde el 2000 de la Escuela de Ingeniería Técnica. Un momento. Escuela de Ingeniería de más de 10,000 estudiantes, donde enseña ingeniería de software. Sus intereses en investigación incluyen la mejora de procesos de software en pequeñas y muy pequeñas empresas, así como el aseguramiento de la calidad de software. Ha trabajado en empresas de la defensa y de transporte por más de 20 años. Obtuvo una maestría en física por la Universidad de Montreal, una maestría en ciencias aplicadas por la Escuela Politécnica de Montreal y un doctorado por la Universidad de Bretaña Occidental en Francia. Fue galardonado con un doctorado honoris causa por la Universidad de San Martín de Porres, Perú, en el 2013. Sin más por el momento, doy el control al doctor Claude Laporte. Claude, thank you very much for all the effort you have to do in order to be with us. Thank you for accepting our invitation to be our key speaker. And please, if you want to start.
Thank you, Mela. Thank you for inviting me. Unfortunately, this year, because of the COVID, we cannot get together, but hopefully next year we'll be able to meet face-to-face. So as you can see, my presentation is about implementing effective and efficient software engineering practices. And the objective, it's not an academic objective, it is a business objective, because we have to provide the functionalities to the customer within budget and schedule. So the content of my presentation, after a short introduction, I'll be talking about quality assurance. Then I'll be presenting very small organizations, and very small organizations are defined as enterprise, public or private organization, or team or projects having up to 25 people. I'll be talking about the standards and the guides that we have developed to support the VSCs. And I will be presenting shortly 4 VSCs that have implemented the 29110 out of hundreds, if not thousands of VSCs. And I will be talking about the benefits of the standards for VSCs and their customers. We'll talk about the next steps about the 29110 series and the conclusion. So what is software? Software, depending from your point of view, means different things. So for professors and students, it means debug code and that has been done as a result of an exercise or a project. And once the exercise or project is done, it goes in the trash can. We forget about it and we go and do the next exercise. For small enterprises, or for many software developers, it means that it is coded software, debugged software, and partially tested. And I'll explain what I mean by partially later on. And for customers that keep the software for a short time, then on top of having tested software, they also want to have some documentation. It could be, as an example, user documentation or installation documentation. Now, for users that will keep the software for many years, when I say many years, it could be 10 years, it could be 20, 30, or 40 years. As an example, the Boeing 747, which is being replaced by new aircrafts, has been flying for over 30 years, and it's still using the technologies of the 1980s. Okay? So those organizations, this is what they want. They want documentations of everything because they will have to support, maintain, modify, improve the software for many years. And most probably, the software developers that were there originally may have left the company or may have been promoted or changed department. So all the knowledge of those initial developers have to be embedded in documentation. So I know that it's not fun and it's not easy, but life is not easy. And if you want to be a software engineer, you have to understand that 80% of your time will be involved in communication, and many or a large percentage of that communication is by writing documents and by presenting documents and by reviewing documents. So this is at the higher, on the top of the slide, it's more computer science, while at the bottom of the slides, it's more what I call software engineering. So using engineering discipline to develop software. So what are the challenges that are facing the industry and as well as government agencies? Because government agencies have short budget, and because of the pandemic, we can expect that in many organizations, the budget for IT will be sustained or maybe lowered. So they want software to be delivered faster. They want quality software. They want cheaper software. They want the team to be more productive. They want no delays, and they want no cost overrun, and they want to be the first on the market. So my suggestion to you, if you want to achieve the lower objective, it's to aim for this objective. If you aim for better quality, you will be able to deliver faster, cheaper, without delays. And I will show you how in a few seconds. So this is on the lower part, the typical phases of a project. After the start phase, we have the requirements phase, the high-level design, low-level design, and then we hit the code phase, unit testing, integration testing, system testing, and eventually shipping to the customer. And on the left side, you see the number of defects that have been detected as we go. So normally, defects are injected at each step of the process. No human being is perfect. So we make errors at each step of the process. But unfortunately, the way that many developers work is they wait until they have code to do testing. And it is during the testing stages that they find defects. And not only defects in the code, but defects in the requirements and defect in the architecture. So my question to you is, what are the problems with this approach? I'll let you think a few seconds about my question. So we have this. Early defects are detected late because we're relying only on tests. When we rely only on tests, we cannot detect 100% of the defects. Okay. And since we were not perfect when we developed the documentation, like the requirements or the architecture or the code, we cannot expect to be 100% right when we will be making the correction to the errors that we've done originally. So all that means that we have to rework. We have to do again previous tasks. We have to do again or modify or correct the requirements, correct the test cases, correct the architecture, update the code, and redo the testing. Okay. And if we have many defects that have been detected during the process, then we may have an unstable environment. And when I say many, we could have 100 defects that we have to fix. Some people are fixing defects in the requirements, other people in the architecture, other people in the test cases, other people in the code. So you can easily imagine that if you don't have a very good configuration management, you could have chaos. And probably many developers will be frustrated by this unstable environment. And the bottom line is you or your organization would have wasted effort, would have wasted time. And since the project will be delivered late and maybe it has been underestimated, then at the end, they might not even be profit to reinvest in the company. And naturally, the software will be delivered late. So the thing is, developers should be working smarter, not faster, okay? And I would say slower will be at the end faster. So the process is, as human beings, we make errors, and those errors will produce defects. and those defects may eventually lead to failure of the software. And the failure of a software could be a blue screen, or the failure of a software could be, if it is an airplane, it could be a disaster. So what we want to do, we want to find ways to prevent the injections of error right there, because it is less expensive to prevent defects than to correct defects later on. And also, we want to improve our efficiencies at detecting defects. So what do we have? So the question is, what is needed to produce quality software within schedule and budget? So I'm showing you like gears of a clock, because in software engineering, we have many processes that run either sequentially or in parallel. So we have to make those things right, and we have to make those things working together if we want to have quality software. Now, the components of software quality assurance are as follows. So we have at the foundation, we have references like standards and models. We have practices like configuration managements, like revisions, reviews, traceability, policies, measurements, verification, code, the measure of cost of quality that I will show you in a few seconds, the use of checklists and risk management. And then we put those elements into a quality assurance plan. And this becomes a foundation to have stable and capable processes, to have continuous training, continuous improvement, and to be able to deliver quality software and have motivated and productive employees. And this means that we have some basic quality assurance function. Now, by function, I mean in a large company, it could be a department. In a smaller company, it could be a team. In a very, very small project, it could be one individual that would play the role of quality assurance. And the bottom line is, for that to happen, we need to have strong management support, because management will pay for the salary of those people that are taking care of quality. So, cost of quality. I'd like to read this citation. This is a strange pattern of human beings, especially in software. We never have time to do it right, but we always find time and money to do it a second time or a third time. So let's go to cost of quality. The components of cost of quality is the cost of execution. See, so if we were 100% perfect, 100% of our effort, of our budget will go into the cost of execution. But since we're not perfect, we have to do evaluations. We have to do reviews, inspection, testing, verification, and audits. And if we are intelligent, we are going to put in place training, methodologies, tools, metrics, and standards in order to improve our process, in order to reduce the last part, the cost of correction, which are the cost of rework. Okay. So my question to you is, in your projects, whether you are in industry or in academia, what is the percentage of your project that is wasted in rework? So rework, again, is redoing things that we've done wrong at the first time. Okay? So let me ask you this question from another point of view. Okay? I'm asking you, because many people that I've met for the last 40, 50 years that I've been involved in software engineering, you say, oh, yes, we know how to manage software projects, and we do a great thing. And now, yes, we deliver quality software to our customer. And then I ask them two questions. I say, what is the percentage of your project that goes into those four categories, and especially in the cost of correction? And I ask them, and so if they cannot do that, my question to them is, are you really managing a project if you don't know that you may be wasting 30, 40, 50% of your effort in redoing things? Okay? And the second question that I ask them are as follows. What is the average defect density that are injected by your organization? Whether it is measured in defects per 1,000 lines of code or per function point or whatever the unit you want to use. And then I say, what is the average defect detected by your organization? Because on one side, we inject defects, and on the other side, we should be detecting defects. And the last question is, what is the quality of the software that you deliver to your customer? So if you cannot answer those questions, then how can you claim, how can you say that you are delivering quality products? So this is an extract from a text published by Mr. Shahat a few years ago. So I'm asking you to guess what is the percentage that is hidden behind this blue box. Let you think for a few seconds. Yes, so it says that 40 to 50% of our work is avoidable rework. In other words, we could have avoided to waste 40 to 50%, or the vast majority of that 40 to 50% in working smarter and not working necessarily faster. Okay? And if you don't believe me, measure the percentage of waste in your projects. Okay? I've been teaching to graduate students in software engineering. Those students are working in industry, and they have unfortunately claimed those percentage. They say, at the first time when I showed them that 40 to 50%, they didn't believe me, but they came back later on and they said, yes, I think you're right. We're wasting a lot of time. Okay. So my question to you is, if you don't change anything, how can you eventually improve? So let's have a look at a few dimensions of the house of quality. The pyramids of politics, processes, procedures, and quality records. So at the first level, we say, why are we doing things? So this is what management says to their employees. At the second level, we have processes, and we say, and we describe what, who, and where things are being done, and the procedures defines how and using what tools. And the bottom are the quality records that we keep to demonstrate to our customer or to a court or to a lawyer that we have been executing the process correctly. So what you want to have is, one is visibility of the process, not like what we have at the lower part. We want to improve the visibility to be able to find way to improve the processes. We want to measure different steps of the process to find where we make errors and how to improve them. And if we do that, then we should be improving our measurements. We should be improving our delivery. We should be meeting schedule. We should be meeting the budget more efficiently. And this is an example of a European company called Siemens. And this is their dashboard composed of 6 metrics. And the trick is you don't want to improve one metrics to the detriment of the other one. So all you have, your objective is to improve those 6 metrics in parallel. So you go slower, but you improve your productivity as you improve your quality and as you reduce your cycle time, and hopefully you will be, by the way, improving your maturity and the customer satisfaction, and also employee satisfaction. Let's have a look now at another dimension, the quality model. So within ISO, there is a standard, the series 25,000, that defines the different quality of software. So we have here a top-level view of the usability, reliability, security, maintainability, portability, and efficiency measures. And those quality definitions are divided in subcategories, as you can see in the lower boxes. And one organization, a consortium, has developed ways to automate the measurements of 4 of those quality characteristics. So it is so useful that a bunch of companies, many companies group together in this consortium of IT software quality, and they have developed tools to automate the measurements of those 4 metrics, those 4 quality characteristics. So as you develop your software, you will be able to measure those 4 quality characteristics. And as a customer, you would also specify the performance you want, and you'll be able to find out if the performance have been met by using the tool that this consortium is developing. So quality is not just academic, quality is in the business. Now let's talk about reviews. So as this diagram shows, we should be doing reviews at each step of the process. Now I'm showing a waterfall or V model, but what I'm talking about is just for illustration purposes. Whatever the life cycle that you use, you should be doing reviews. Okay. And I let you read this. So as you perform reviews on others, people work and on your own work, you learn about your own mistakes and you learn about the mistakes of others and you improve your own work. So the next time that you do a similar product or similar document, you will have less defects. And let's have a look at the real company. And this is the number. So at the bottom, you see the different phases of the life cycle phase. And you see the percentage of defects. So what I'm illustrating here is about 50% of the defects were injected in the requirements phase, and another 20%, 21% of the defects were done in the architecture phase. So it means that 70% of all the defects were injected before one line of code was written. But most organizations still wait until testing to find those mistakes. That's not very logical. So I think now you understand why we are wasting a lot of time. Because if you make defects in the requirements and you find those defects only when the code is available, then it means that you have to go back and redo a lot of things. Now, good news, within the same company, Northrop Grumman, they published this result. So it means that at each phase of the process, they have put in place mechanism to detect defects and correct defects. So their mechanism is not perfect, nothing is perfect, but as you can see, in the requirements phase, they detect 96% of the defects. So, and nationally, they correct also those defects. So instead of finding the defects way down in the life cycle, they find them on the spot before they damage or they corrupt the next phases of the project. And what are reviews? Simple. So this is the first part. When you develop a document, you've got your source document, and I'll give you an example and maybe template, and you do your activity and you have your software product. So as an example, you have as an input, a contract from the customer, you have system specification, and you have your software specification template, and the output are the software specification. So once you've got that, you can go into the review mode. Again, you use the output of your work, and as you do review, you produce a list of defects. You will have measures. You may have change requests, and you will have a corrected product. So those are the inputs and the outputs for this process. So this is a learning process where you find the anomalies or the defects, you correct those defects, and you measure the time that you took to detect the defects, you measure the time that you took to correct the defects, and for the next project, if you learn by improving the templates, by improving the methodology, your project should be more efficient and you will have less waste. So this is the same curve that I showed you before, but by doing reviews, you will be detecting defects in all phases of the project. So you'll be working smarter. Okay, the objective is to work smarter. And let me give you a quick example of a company, Rolls-Royce. They manufacture jet engine. So when you fly on aircraft, typically you will have 2-3 manufacturers of jet engines, and Rolls-Royce is one of the big manufacturers. So what they have discovered is the auto effectiveness vary by a wide factors. So the number of defects injected in this example varies between 18 defects per 1,000 lines of code to 0.5 defects per 1,000 lines of code. So there is a variation of a factor of 30 between the best people and the less good people. And same thing for the defect removal effectiveness, there is a factor of 3. So it varies between 30% and 94%. So 30% means that author, when it reviews its own document by itself, will detect only 1 defect out of 3. So this is why we have peer reviews where other people with hopefully higher defect removal efficiency will be able to detect more defects. Now let's move to the standards, because this is a very important part of software quality assurance. And I will be talking about the ISO 29110 standards, for which I am the lead editor. So in a pyramid of a company, and this is a real pyramid from a real Japanese manufacturer. So at the top, the manufacturer, you've got that company, which I will not name, but it is a famous Japanese company. And that company has to use or supply or subcontract to what we call prime suppliers. So they have 60. And also at the lower level, they have 600 suppliers. And at the bottom level, they have 6,000 suppliers. So what happened is one of these low-level suppliers made a defect in one component that has not been detected, and it was mass-produced by the manufacturer, and it resulted in a cost of over 200 million to this manufacturer to correct the mistakes and update the products and ship new version of the product. So my point is, we have VSEs at each level of this pyramid. Even in large organizations, like the one at the higher level, they have VSEs. They have small teams, 2, 3, 5, 6 developers that are working in a team. Even if the company has 1,000 employees, they have small teams that are developing software. So within ISO, we have a committee called Committee 7 that develops systems and software engineering standards. And this is my working group, and the flags and the logo that you see are the flags of the countries that are participating to the development of the 29110. And we've been working on those standards and guides that I'll show you in a few minutes since 2005. And you see many flags from Latin American countries. So the way that we have developed our document is like the Russian dolls that you see at the bottom of the slide. So a lower guide is a subset of a higher guide. So the entry guide is a subset of the basic guide. So in other words, once you have put in place the entry guide, then you just have to add a few tasks and a few work product to get to the basic level. Same thing, once you have the basic level, you get to the intermediate level. And I'll show you what I mean by those levels in a few seconds. Okay. So the 4 levels are the entry. So very small projects of 6 person months or less, or startups. And the basic profile is for a VSE that has 1 project in 1 team. Then the intermediate project is for a VSE that has more than 1 project and more than 1 team that are working in parallel. And the advanced profile is to help the VSE to grow and sustain, because the death rate of startups is very high. Typically, 80% of startups will die within the first 5 years of their establishment. And I will show you that the guides that we have developed are mostly available freely. And the good news is also the guides have been translated in Spanish. So here I'm showing 3 of those. On the left side, the overview document. In the middle is the entry profile guide. And on the right side is the basic profile guide. And I'll show you in the next slide what I mean by the basic profile. So here we have a customer that knocks at the door of a VSE with some description of what the customer wants. We call this a statement of work. You could use other terms, list of requirements. And the management of the VSE will decide if it will do this project or not. If it decides that it will do the project, then the project management process will be triggered, and the project manager will do a project planning. And once a project plan is approved, then it will start to execute the project plan. And those are the typical activities of the software implementation process. The first one, the implementation initiation, is a very short activity, and it's like a kickoff meeting. We want to make sure that every member of the team knows what are the objectives of the project, know what the process they will be using, knows what the teammates are doing, which tool they'll be using. So after 30 minutes or so, this kickoff meeting is done. And as you can see, the other steps are the standard software engineering phases. And as you develop the software, you evaluate against your plan to see if you are ahead or behind the plan, if you're spending more money. And if you have to, you will be making correction. And at some point, the product is ready and the project will be closed and the software will be delivered to the customer. What I mean by software configuration is naturally the code plus all the documentation that the customer required. As I said, it could be the installation manual, the user manual, it could be the test cases, whatever the customer wanted, it will be delivered. Now, it's not because I'm showing you things in sequence that you have to do them in sequence. It is just for illustration purposes. See those white boxes in the project management process and the software implementation process as Lego blocks, and you can assemble them to meet the needs. It could be in agile mode, incremental, or evolutionary mode. Okay, so don't see this as a pure waterfall that you have to use. This is a guide, and assemble those mini Lego blocks the way that you want. So let me give you an example of a task. So at the high level, we have the process. Process is supported by activities, and in each activity, you have tasks. So the left side, we say, for this task, the customer and the analyst will participate. And this task means that you'll validate and obtain the approval of the requirement specification. Here you have some details about this task. The end products are the requirements specification that have been verified. By verified, we mean the defects have been corrected. And the output are the requirement specification validated, and naturally a little report talking about the result of validation. I'll show that to you in a few seconds. So all the steps of the process are described this way. If for those of you who do cooking, it looks like a cookbook recipe that you follow. Now, if you don't like the words, you can change the word. The guides are not a Bible. So if the words that we use in the guide do not meet the words that you use in your own organization, please change the word. But you've got here the concept, you've got the steps to start with. And I said that we provide also descriptions of documents. So this is the result of validation. And we say that typically this document, by the way, when I say document, it could be an electronic document. It contains this information and it is triggered by the software implementation process. So let me show you 4 VSCs that have implemented 29110. So one startup in Peru that was established in 2012 used the basic profile in an agile mode. And on a project of over 882 hours, they had a percentage of rework of 18%. And I want to remind you that this startup was using the basic profile for the first time, and they only had 18% of rework. And if I had time, I would show you how they got this number. And by the way, they also obtained a formal ISO certification in 2014. Another company that developed cosmetics had only one software developer, and they used the entry profile for a small project with 12% of rework. Another IT startup of 2 people used the basic profile on a 990-hour project with 12% of rework. And the last example, I told you that the definition of VSC means small teams in large organizations. So this is an example of a very large IT organization of almost 2,000 people that supports over 2,000 applications. But in this big organization, they have also a small team. So they have a team here of 11 people, and they had used a basic profile with Scrum on a 1,500-hour project with only 9.6% reward. So I'm showing here the data published from the company called Raytheon when they were moving from different maturity level, CMM maturity level. So when they started, they had 41% rework. And as they did improvement, they went from 41% to 18% at level 2 to 11% at level 3 and to 6% level 4. So what I'm showing here is the IT startup for their first project had only 18% rework. The IT startup in Canada at 12.6, the public services at 10.6, and the cosmetic organization has only 12%. So my point here is if you implement proven practices that are documented in 29110, then you're accelerating your maturity. So instead of making the mistakes that other people have made before, you're using proven practices to save time, save effort, and produce quality work. So let me show you a survey that we've done 2 years ago. We wanted to ask our users, the VSCs, we want to ask their customers, the auditors and professors if they were happy with the documents that we produce. And I would like to thank Dr. Mirna that has nicely and gratefully translated our English survey in Spanish. So the first thing we ask them is, are you satisfied with the result that you have obtained? What I mean by satisfied, we ask them also if they had improved the productivity and improved their quality. So as you can see, a very high level of VSCs were highly satisfied about the 29110. We asked their customer, and as you can see, 79% of their customers said that they were very satisfied about the completely or largely satisfied about the results. In other words, about the software they were delivered by a VSC that has been using 29110. So it's a win-win situation. The VSC is satisfied and the customer is satisfied. And we also asked academia why they were using 29110. And as you can see, for different purposes, either to teach basic software engineering, basic project management, to teach the standard, to teach software quality assurance, and also because local company or government organization wanted the 29110. Okay, so this is the portfolio of 29110. I just want to focus on 2 documents, the Agile Guide. And the Agile Guide is being developed by a team of people from Mexico, of which Mirna and Yazel are the lead editors. And we are going to review the document, and it should be published next year. So in 2021, the Agile Guide will be published. The DevOps Guide, we should get the first draft of a skeleton of a DevOps Guide at our meeting in December. And we should have a DevOps Guide available towards the end of 2021 or more probably early 2022. And we are now also involved with the space domain. A group of space agencies got together and they found out that the basic profile was good enough for them to impose to their suppliers. So we are now developing a standard and a guide to help the VSC that are developing software or maintaining software for the space domain. And if you want to know more, please have a look on my website. I have pages in English, French, and in Spanish. And most documents that you will see, all documents that you can download are totally, you can download them totally legally, okay? So the house of quality that I've showed you earlier, what's in red are the topics covered by 29110. So my message is if you start with 29110, you would have already put in place many quality assurance practices. Okay, and this house of quality that you recognize come from the book that I have developed with a colleague of mine at ETS. And we got a very good news a few weeks ago that our book will be translated in Chinese in 2021. And most probably it will also be translated in Spanish somewhere in 2021 or 2022. So what does it mean? Beside the fact that I'm very happy, it means that other countries have found that the House of Quality and this 600-page textbook could be used and taught to undergraduates and graduate students, and could be used by people in industry to learn about software quality assurance and to put in place software quality assurance practices. Okay, because in this book, it's not theory, it's practical stuff, as I've illustrated to you. Now, what are the benefits of 29110? So I'll let you read this slide. So those are the day-to-day benefits, but on top of that, there are also commercial benefits, business benefits. And this is very important because when a business has happy customer, the customer will come back for other products, other projects, and the happy customer will talk to his friends and colleagues, and they will refer the VSE, your VSE, to them. And on the other side, as you know, when you're not a happy customer, you talk to many people not to go to this place, and you will not recommend your friends and colleagues to go to this place. So it works on both sides. So the reduction of rework, as I said, brings many benefits. Okay, higher profit margin because you will be wasting less money, less time. Okay, so it means more money to invest in new products, in new development, in improvement, shorter development time, and being more competitive. And if you want, also you can obtain a certificate of compliance. So in conclusion, a wide spectrum of software quality assurance are available to develop quality software products. Software quality assurance will increase the level of confidence that you'll be delivering quality software within schedule and budget. Now, I mean a level of confidence because no software engineering standard can guarantee 100% that you will never make mistakes. But we can help you in improving on a daily basis your productivity and your quality. And this is the objectives of quality assurance, and this is the objective of 29110. You start where you are and you build on your projects, and every new project you should be improving the quality, you should be improving the budget, and you should be improving that you're meeting the schedule. Also, the 29110 has been developed specifically for VSEs having up to 25 people, for the VSE that produce software or system. By system, we mean that you have hardware and software, like your computer, your cellular phone, or systems. And finally, we have provided the 4-stage roadmap. Remember the entry, basic, intermediate, and advanced profile of management and engineering guide to help you to grow from startups to grown-ups. Now, why have we included management? This is a very important thing. Most technical people are very good at doing technical stuff, but many, if not most technical people, do not like to do management, or they don't want to do management, or they're not very good at management. But we have years and years and years of experience showing that if you don't do basic project management, you may fail. You will be delivering late, you will be delivering over budget, and your customer will not be happy. So this is why we have included in all the guides of 29110 a basic, very elementary project management process that you will follow and will help you produce quality software. So my questions to you is, why do a large number of software organizations either ignore the existence or don't use software practices that have been available since the 1970s? So we're talking 50 years. Practices that have been available for 20, 30, 40, 50 years. Why are they not used by yourself, by your team? either in academia or industry or government organization. And my question is it because many software developers and managers have a big ego? Oh, I don't need that. I'm better than that. I know that. I don't need a standard to tell me what to do. I don't need a guide to tell me what to do. I'm so good. Okay. So my hypothesis is maybe we have too big ego. And the last point is, why are so many people not working smarter and not using proven practices? So if you use the practices that are embedded in software quality assurance, house of quality, or in standards, you'll be working more intelligently and you'll be working smarter by using proven practices. What I mean by proven practices is the experience that we have gathered since the first project that have been developed back in the 1970s. We have learned from the successful projects and we have learned from failed projects, because sometimes we learn more from failed projects because we discover when we do lessons learned what we have done wrong. And those lessons learned have been embedded, documented in the standards so that you don't have to do the same mistakes that have been done 40 years ago. And I'll be open to questions if we have time. Thank you very much.
Thank you very much, Claude. Unfortunately, we don't have time to questions, but very interesting and important talk, especially for industry, because most of the time as industry, we think that it doesn't apply to us, but as you mentioned, it's very important. Muchas gracias, Dr. Laporte. I'm going to speak in Spanish, sorry.
Oh, just before you switch me, if you want to ask me questions, because we don't have time for a question period, if you want to ask me questions, please send your question to Myrna, especially if they are in Spanish. I can use Google Translate, but sometime Myrna will do not sometime, but Myrna will be a better job than Google Translate to translate your Spanish question for me in English. And I will be very happy to answer your questions. So please do not hesitate. If you have questions, send them to Myrna. And it may take a few days, but I will answer all your questions. Thank you very much, Myrna, again.
Thank you very much, Claude. I'm going to read the acknowledge for the conference. So, por favor, Santana, ¿puedes poner la constancia? Si tienen preguntas, por favor, escribirlas aquí en el chat y nos encargamos de que le lleguen al Dr. Laporte y que él pueda muy amablemente respondérselas. Claude, in the name of the Mathematical Research Center and the Mazatlan Informatics Faculty and teams, we are giving you the knowledge for your presentation, implementing effective and efficient software engineering practice to develop or maintain software products that provide requirement functionalities with quality, within budget and schedule. Thank you very much for all the effort, time, disponibility to be with us, and I hope to see you next year. Thank you very much.
Oh yes, I'll be with you in Mexico for SIMS 2021.